Okay, so with all the preparation and learning about neural network, especially convolutional neural network, let's use the net, very classic network architecture, uh, to our real project. So in this week's project, we are going to work on the traffic sign classifier. So everything is pretty much the same as shown here, except that, as I mentioned earlier, we are going to use the ReLU activation functions for the hidden layers. And let's go to my write-up. So for this traffic sign classifier, there are going to be a few steps to start with. So the first thing is we need to load the data, and I think in general a good practice is always to check the data size and distribution just as a sanity check. And then we are going to visualize the data set and then implement the model and do some training and also test on the test data. And in the end, we are going to try if we can get a decent accuracy for making predictions. Okay, so let's just get started. Yeah, just in case, whenever you have some questions, always good to refer to the rubric points before you make further improvement or make any modifications. Okay, so as I mentioned, it's always good to do a quick overview of the data set we have. So we have already got the provided training, validation, and testing data. So here I'm showing that training set is pretty huge, about 34,000, and each one is a 32 by 32 by 3 color image. Yeah, one thing to note that just to speed up the training process, we are going to do some pre-processing of the data. Namely, we don't directly work on the 3 RGB channel image. Instead, we are going to work on a grayscale image. And note that turning the color image to a grayscale image, we actually didn't lose much, right? Yeah, just like if you wear a sunglasses, you can still see a lot of the signs. Yeah, all the information is pretty much maintained. Yeah. So as I said earlier, other than checking the input image size, it's always good practice to make sure that your training and validation and testing sets are from a same distribution, just as I shown here. Otherwise, the model you train, if it's going to be applied on a different distribution of testing set, the accuracy will not be guaranteed. Okay, so that's pretty much all the preparation for the actual training training test. Yeah, so the actual neural network stuff start here. So you are going to design and test a model. So the model is pretty much well defined based on the net. We have input and convolutional layers. And note that the typical structure is we have a convolution layer followed by a ReLU layer and then a max pooling layer. And after a few operations of convolution and these subsequent operations, we are going to use a few fully connected layers, and finally the softmax to give the output. Yeah. And here, if you want to stand out, I would suggest trying to play with the hidden layer just to see what CNN is doing inside the hidden layers. Try to see the features it's trying to detect or extract. And that's pretty much it. And note that there are a few parameters and hyperparameters that you can tune. So empirical numbers, I typically use what is recommended in the lecture. So here, the batch size for training is about 128, and the rate is about 0.001. And depending on how your initial model looks like, you can always have the regularization and the regularization lambda adjusted. Yeah, for me, these numbers seem to work fine. Yeah. So in the end, for the write-up, it would be nice if you could give a few examples about the training. Some may be successful, some maybe not, but if the model overall can get a test accuracy about 0.9, the model should be able to handle most of the images. Yeah, so the actual code is going to be written in the Python Jupyter notebook, and all the blocks can be separated, and all the output of the blocks can also be saved, and this will be a nice for you to track the progress. So with that, I think I'd like to finish this quick introduction of the project, and if you have more questions, feel free to leave me a note or send me an email.